Welcome back to another video on Leet code coding series. So to continue our arrays data structure, we will solve a new problem, that is remove duplicates from sorted array, and this is the last problem of each section. After that we will only solve medium and hard problems of array data structures at Leet code. Also, this problem is very easy. You can try with your own, and there is no any algorithms you can use to solve these problems. This is only the logical, like logic based question. So here you have to first read the description of question. What is that? So simply, it is an integer array because we have given an integer array nums, and it is in sorted order. Okay, in non-decreasing sorted order. That means some elements may repeat, and also we have to remove the duplicates. We have to remove the duplicate cell elements in place such that each unique elements appear only once. The relative order of the elements should be kept the same. So it is possible to change the length of the array. So some language you must, instead of result to be placed in the first part of the array nums. And more formally, if there are k elements after removing their duplicates, then first k elements of num should hold the final result. It does not matter what you leave beyond the first k elements. It may be anything. So return k after placing the final result, the first k slots of the nums. So here, do not allocate any extra space. So one thing you have to ensure that to solve this problem you don't need to use any set, because you can solve this problem using set also, but here you don't need to use any extra space for another array, because we will modify the same input array in order of one extra memory. So that is the thing. So understand by the example. That is all about the question. Now understand by the problem statement with the example. So here we have given an integer array nums, and that is 112. It is in non-decreasing order. Okay, and it is sorted. So here you can see that the number ones are repeating. Okay, it's 112. So what is the size of non-repeating elements, or you can say that the distinct elements array size? So it is simply 2. We have to just count the distinct elements and we will return it. And also you can notice that the nums array, we update the same nums array. So here we will return k is equal to 2. That is basically the distinct total number of distinct elements. And also in that nums array, the first two element must be 1 and 2. Okay, and we will not care about other elements inside the nums array. It may be the underscore, it may be the same element, it may be anything. So that is our problem. So now I'm just gonna solve this problem. So you're gonna ask me, how can we solve this problem? So I'm just gonna tell you that it is very simple. So first thing is that we have to notice where the elements, where we will know that that elements is, so where the elements are like chains. So suppose you are at like 1. So in the second example, think about the logic. What is the logic of this like problem? So here 0 0 1 1 1 2 2. So you can notice that when you reach at 1 1 1, so the elements are same here, but when you just go after 1 and then you will go for 2, so there the element change, the element is increasing because it is in, yeah, sorted order. So here you will just focus on that. When the element will change or increase, you will just put that element inside the nums array from very beginning. So here I'm using a for each loop for accessing each element of nums array. So here I'm just using integer e and nums. Sorry, yes, that should be column nums. And right now, one thing you have to say me that also we will just increase the nums element. We will start from the very beginning. So here I'm using a variable int p is equal to 0. So I didn't need to, like, because the value of p should be increased, so I have to declare it before the, yes, for each loop. And here what we will do, so here if any elements, so inside the if condition, simply we have to put, understand, I will write the if condition after that, nums of p, and we will put that element inside nums of p. Okay, and what is that e element? It is simply if that element is not already present in that nums of p. That means what? That means that is not present. If think about in this situation like that, suppose 1 1 1, these are the repeating elements. So we already suppose put in that nums at this index, but again we found that, like, we again found value 1. Okay, so we will not put that one inside the nums p. So we will, when we will put, if we will find another elements. Maybe it is any element, but it always greater than that one. So if we will find any greater element, so we will simply put that element inside num sub p. So here we will start from very beginning, like from index 0. So I'm just increasing p plus plus. Why? Because initially it was 0. Also, one thing you have to tell me, that what about if the element is like come at very beginning, so how we like put that element inside the num sub p? So we have to just is kind of base condition kind of, so we have to just write it. Okay, so if I is equal to 0, so for that we have to handle it this condition. It's a kind of current condition. So if I is equal to 0 in the very beginning, we will just put simply that element inside the nums of p. And after that, we will check with every elements. So here, what we will do, if the value, so here, if the value, what value? The value e is greater than which value? Greater than the last previously stored last value, that is nums of p minus of 1. If e is greater than nums of p minus of 1, we simply, that means suppose 2 2 3 3 4, so we already stored 2 inside the nums of p, and we increase the index p by 1, and here we again reach at next element, we found that 3, and here it will check if 3 is already stored at the previous index like p minus 1 or not. So if it is not there, we will simply, okay, so we will check that if it is greater than nums of p minus of 1, so we simply put that element inside the nums array, and we will simply increase the array index. Also, we can notice that if the array size is like distinct element size is 5, so we can only put the 5 element inside the nums array. And what about the remaining elements? We will not care about that, it may be any element. Okay, so why we will stop there. And here what we will do, we will simply return, because it is increasing the value of p, so simply we will return what? Return p, that is the basically the size, and we already updated the nums array. So this is our program. It is very simple. Think about the logic, think about the problem. Okay, so here it is given an error, so sorry about that. It is should be p, our index is p, not I. Yes, that's good. I'm just gonna submit this. Okay, fine. So you can solve this problem by your own, and this is all about today's lecture, guys. Okay, so in the next lecture we will solve a new problem, and you will find that. And if you are new to channel like on Cyberson Academy, and here in this series we will solve 500 plus lead coding interview questions, which basically asked in interview, or maybe you can like that may be asked in interviews. So you have to just please do subscribe to the channel, and also share this video with your friends. Thanks you. What is the time velocity? It is simply order of n, and here I'm not using any other space, simply using another single variable, so it is order of 1, the space complexity.